Assalamualaikum warahmatullahi wabarakatuh. We are from Group 3.
Now, we would like to presenting our presentation that entitled Implementation of Euclidean Algorithm. Now let us introduce ourselves first.
My name is Ardi Sejati.
My name is Muhammad Bian Suryoprakoso.
My name is Gloria Yoland Septryana. Now, the first thing that we would like to explain is about the definition of algorithm. An algorithm itself is a step-by-step method of solving a problem. It is commonly used for data processing, calculation, and other related computer and mathematical operations. An algorithm is also used to manipulate data in various ways, such as inserting a new item, searching for a particular item, or sorting an item. Now I will explain about the function of algorithm. The first one is simplify a program. That is mean help to simplify a program that's big and complicated. The second one is minimalize a program. It means minimalize a program that's written more than once or one time. And then the third one is help to solve a problem with logic and systematic. The fourth one is help make program more structured. And then the fifth one is to minimize program writing repeatedly, like the first one. And then the next functions of algorithm are to make it easier to make programs more neat and structured so that they are easier to understand and to develop. And the next one is to facilitate the process of modification in the program because it can be done only on one module without having to change the other one or the other module. And then the last one is when an error occurs, the algorithm can help find it because of the clear workflow.
Definition about Euclidean algorithms. A Euclidean algorithm is an algorithm used to find greatest common divisor, GCD, or commonly known as faktor persekutuan besar, FPB, of two numbers or integers by dividing the larger by the smaller by the remainder, the first remainder by the second remainder, and so on until the remainder 0 is found. Okay, history of Euclidean algorithms. In 1950, the algorithm was used in Euclidean algorithms, or Euclid's algorithm. Both of them, it was the same. Euclidean algorithms was discovered by Euclid. Euclid is a Greek mathematician born 350 BC, and Euclid had a book called Euclid's Element, and which contained steps for finding a greatest common divisor, GCD, or commonly known as faktor persekutuan besar, FPB, of two numbers or integers. And Euclidean algorithm is the one of the oldest numerical algorithms and is still widely used.
And now I'm going to explain how Euclidean algorithm works. First is Euclidean algorithm, we have the basic and extended. So what is the difference between basic and extended? The basic is only like the simple one, and the extended we have the formula. So the first is this. Now, Euclidean algorithms, basic and extended. So the great common divisor of two numbers is the largest numbers that divide both of them. A simple way to find a great common divisor is to factorize both number and multiply common factor. So we have this 36 and 60. So we have what's generate 36? So we have 4 times 9. So we have to factorize 4 and 9. So we have 2 times 2 and 3 times 3. What about 60? We have to generate about 4 times 15, right? So we have this. So when we factorize is 2 times 2 equals to 4, and 3 times 5 is 15. So we have it 60. So the multiplication of common factors is we have this. We have 2 and 3. So we put 2 and 3 because we have 2 is 2 and 3 is 3. And 3 is 2. So we put 2 and 3. What about 60? Because we have only 3 and 5 is only 1, so we don't input the 3 and 5. So we just put 2 and 2. We just input 2 because 2 have 2. So we have 2 times 2 times 3. So equals 12. Now this is another example of the great common divisor. So this is it. 14 and 15. 14 we have 2 times 7 equals to 14. About 15, 3 times 5 is equal to 15. So the great common divisor of 14 and 15 is 1. Okay, because 14 in because this is only a prime number, so we just input 1. Find the great common divisor of 25 and 35. So we have 25 is equal 5 to 5. And 35 we have equals to 5 times 7. So we have the great common divisor of 25 and 35 is 5. Why? Because we have 5 is 3. So we put 5 because that is the most of them. Okay. That is the basic. So how about the extended Euclidean algorithm? So now we are working great common divisor with formulas. We have ix plus by equals to great common divisor of a point a comma b. Okay, a point b. So we have the example is s and t is 56 and 15. Now this is the example of working on it with formula. So we have 56 and 15. Now, what is the close number to 56 from generate of 15? So we have 45. So 15 15 times 3 is equal to 45. This is the rest of 56.66 minus 45. So we have 11. Now working on it like this. We have 15, we have 11. So what is the closest number to 15 that generate from 11? So we have 11 itself, so we just times 1, and with the rest remaining is 4. This is the process until we have this, the last number, which is the smallest numbers. Okay, 4 and 3. What is the nearest number that generates from 3? So which means it's 3. So we have uh, uh, we have this 3 times 1 is 4. Okay, 3 times 1 is 3, and 4.4 minus 3 is 1. So this is it, and we have to transfer the equals to the right side. So we have this. Okay, now this is the rules. Strike the underline like variable, and we have to working from bottom to up now. Okay, now we have this, the formula. So the first is we put the below number. So we have this 4 minus 3 in the column is 1 equals to 1. Okay, we just put the, so how do we work is because we just times like a rainbow. So 3 times 1 in the column, so we have 3. Okay, now this is the working on it. So this is 4, just transfer 4 to the bottom, and 3, this is 3. Okay, this is variable 3. So this is the number of 3. Okay, we have 11 minus 4 in the column is 2 equals to 3. So we change 3 into this, okay, like this. And this is 4 minus 11 minus 4 in the column is 2. This is in the column. So how do we erase the column? This is it. This is 4 minus 11. So we we change the column in the we change the minus and positive in the in the inside of this column. Okay, move it, and this is the, so we change the positive and minus and positive in the column. So we have positive because we want to erase the column, and this is change side. Okay, 2 and 4. Now after this we input this, because this is for like variable, so we have 1 in the front of 4 and we have 2, so which means we just together itself, and we have this 3 4 minus 11 equals to 1. This is minus, sorry, I'm putting the wrong, yeah. Okay, now first is this 3 15, this is 4, now this is 4, it is this 4. Okay, 3 in the column is 15 minus 11 in the outside of the column, and minus 1, so we times like a rainbow, so we have this 3 times 15 equals to 3 minus 11 minus 11, so we have 4 in the column is 11, so we have this, and in the next step is 3 times 15 minus 4, so this is 11, so this is the 11, this is variable of the 11, so 4 under column is 56 minus 3, and underline is 15, so this is the times like rainbow like usual. 4 times 56 is 4 times 56, and we have minus and minus, we change it to the positive, and we have 4 times 3 is equals to 12, and 4 and 12 times 15, so we have this, and then we the next step is to apply. What is 3 minus 3 times 15? So we have this, okay, 3 plus 12 is 15 times 15, and we have minus 4, not 15 and 1, so we have it. So this is the great common divisor of finding S and T, so we have this 15 and 4. Okay, I hope that explained about the great common divisor in the formula, and next is going to Bian.
Implementation of Euclidean algorithm. One of the implementation is a program application of Euclidean algorithm theory. The main function of this program is, well, will let us easier to find the GCD, or commonly known as FPB. Okay, faktor persatuan besar. Okay, so this is one of the implementation, is a program application of Euclidean algorithm theory. So the first thing is the program asks us to input the first number, which is greater number, and the second one is a smaller number. Okay, A, and after you enter the number, the program will calculate it. Okay, A colon B equals A divided B, remainder. So, okay, let's move to PyCharm. Oh, we use Python language for writing this source code. Okay, so this is the source code. Okay, this is while syntax, because we have to loop until the remainder is 0. Okay, while hasil isn't 0, it will looping until the hasil is 0, the remainder is 0. Okay, in while syntax, we have to change A equals B, A variable equals B, and B variable equals hasil. Why? Because I already told you guys about the principle of Euclidean algorithms by dividing a larger number by the smaller, and the smaller by the remainder, and the first remainder by the second remainder, and so on until we have the remainder is 0. Okay, so let's run it. Okay, the program asks us to enter the numbers in the integer. The first number is greater number. Okay, for the example is 1980. Okay, so enter. Okay, the second one is the smaller number. For the example is 29. Okay, after you enter the number, the program will calculate it. Okay, let's see. This is a variable divided by b. Okay, here divided by b equals the results of a divided by b, and it has a remainder 8, which is a variable hasil. Okay, so on the principle of Euclidean algorithm is a larger number divided by a smaller number, and it has a remainder. Okay, so this is a second calculation on while syntax. Okay, we already changed the variable a equals b and b equals hasil. Okay, so this is an a variable but equals b. Okay, before that is b variable, and this is a hasil. Yes, and we already changed to hasil equals b. Okay, on here. Okay, back on the principle of Euclidean algorithm. Larger divided by the smaller, and the smaller divided by the remainder, okay, which is 8, and it has a result, and it has a remainder 2, which is 5, which is a second remainder. Okay, and the first remainder divided by the second remainder, and it has result, and it has remainder 2, which is 3, and so on until the remainder is 0. Okay, so the GCD or FPB from the two number is 1. Why? Because what is taken GCD, what is taken is before the remainder 0. Okay, before the remainder 0 is 1, which is 1. The GCD or FPB from two number is 1. Okay, and then the sentence the GCD or FPB from the two number is 1 is it's from the else syntax works. Okay, in while hasil isn't 0, after we have found a remainder is 0, and it jump out to the else syntax, and the else syntax will print the sentence. Okay, so this is the output of the source code. Okay, this is an output. Okay,
So now I will tell you the conclusion of our presentation. Our presentation entitled Implementation of Euclidean Algorithm. So the first thing that I would like to tell is about the definition of Euclidean algorithm. Euclidean algorithm itself is a method of finding the greatest common divisor of two numbers by dividing the larger number to a smaller number. And Euclidean algorithm have two types. The first one is basic Euclidean algorithm, and then the second one is extended Euclidean algorithm. The extended Euclidean algorithm is more complicated than the basic one. And then, for the implementation, our teams choose to make a program application of Euclidean algorithm. This program is written in Python, and we think that this program will help people in need for finding the greatest common divisor, because this program application can easily find the greatest common divisor of two numbers for the big numbers that is really hard to find it in a manually way.